Okay, so Newton's second law states that the net force equals mass times acceleration. What is this saying? Well, net force represents an unbalanced force, okay? So a net force means that the object is accelerating, all right? When a net force is being applied, the object accelerates in the direction of the net force. And this equation is saying that net force equals mass times acceleration. And basically what this means is that you have to apply more force to push a heavy object than you would if you were trying to push a light object. Okay? Heavier objects require more force than lighter objects. Alright? The other aspect to this equation is the idea of, well, what if the force you're applying to an object is equal, but the masses are different? Okay? So what if I'm trying to push a rock that is fairly light? Okay? I can accelerate that object at a pretty high rate of acceleration because it's light. It has a really small mass. But then I go over to a larger object, maybe a big rock with a much larger mass, and I try to apply the same force to it that I used with that small rock. Well, now I'm not able to accelerate that rock at such a high rate anymore. Okay? And that's what Newton's second law explains. When you play around with the equation, you'll realize that the force that you put on an object depends on the object's mass, and the acceleration that results from it also depends on the object's mass. Okay? They're all dependent. They're interdependent on each other. So, Newton's second law, force equals mass times acceleration. Now, there's another part to this if you play around to the equation, and we'll talk about that next. But for now, Newton's second law states that force equals mass times acceleration.